Start off today with a talk about reproducible builds from Chris Lamb, and then we have a couple other agenda items on the malware analysis project, and anything else people want to add into here to wrap up for today. So yeah, add some stuff here. I think up next we next presentation. So 2 weeks from today, somebody offered to give a demo on Tracy, if that's the right way to pronounce it, which is another syscall monitoring system. So that'll be up in a couple weeks. If you have any other demos you'd like to add, throw those up into the upcoming or next section.
Dan, while we wait for everybody to join and type in their names, can I tell everybody about the upcoming town hall?
Of course.
Okay, so upcoming town hall, February 22nd. It's 1 to 2 p.m. Eastern time. Adjust to whatever your time zone is. Please register. There's a link right there. And it's only for an hour. It's basically just a quick summary of what everybody else is doing so we can all have an idea of what's going on. So thank you very much.
All right, then. Do you want to jump in, Chris?
Sure. I guess the first thing I want to say is thank you very much for inviting me along. Thanks for Derek for the introduction. I recognize a few faces and even more names. So if we've talked elsewhere or on email, hey, how you doing? Hi. I guess a little brief introduction about me, if that's really helpful at all. So Chris Lamb, I live in Cambridge, UK. And I've been in open source for, well, if you count sort of university, like mucking around with it, maybe 15 years, but like sort of professionally for 10 years. So like a freelancer, working with various companies doing open source and or definitely everything using open source frameworks and things like that. I was the Debian project leader from 2017 to 2019. And I'm currently on the board of the Open Source Initiative. So that's like, credentials are a thing, but like that's kind of thing. But yeah, so I've been in open source space for a while and things like that. So and certainly much more on, say, like the community sort of distribution kind of level, things like that. Oh, thanks for someone who's taking notes. I can't see who's doing that, but thank you very much.
You can blame me, but others can chime in. Please do, in fact.
Oh, that's great. Yeah. Anyway, enough about me. So reproducible builds. So this is my first. Sorry, I'll get my pen here. This is my first appearance in your working group meeting, and I'm guessing you need no introduction to sort of software supply chains and things like that, and how these are like extremely critical, and basically how the world works and things like that. And then all the repercussions from that. So if your supply chain is vulnerable, then you are vulnerable and things like that in ways that are quite pernicious and things like that. So yeah, in terms of reproducible builds specifically, I think if you come away from this with like one takeaway. But like reproducible builds, it's like a terrible name, but like a really good idea. So I didn't come up with this name, but like the idea of what gets hidden in the slightly confusing name, like no one really cares about like is your build reproducible or not? Who cares? But like the problem that it solves is really big, and like it's a really serious issue. We've had over the past 2 or 3 years, I've been collecting various news articles about various supply chain attacks that could have been prevented with reproducible builds, or detect, or at least detected earlier. We can at least say that. And then we had some. We had one recently in December. Apparently, there was lots of other news going on in December. I don't know if you saw any of that. So this meant that the big one, the SolarWinds attack. Oh, I see some going on the notes here. David wrote a really good post about SolarWinds on the LF blog and things like that, and it's all around. It's in your glossy magazines that you get every Saturday as well. So yeah, so like the other problem we're trying to solve here in the supply chain, like put it this way, I always try to like underline the seriousness of this, and you can go through like bits in the past, try and show how different these kind of attacks are done have like caused serious problems in the past. The other problem with reproducible builds is like most people may have a sort of compromised, people who are running stacks at the moment might have a compromised system already and they just don't know it. I mean, given the number of people on this call and like some of the organizations you're in, it wouldn't be too much of a stretch to think that you've been compromised already and you don't really know. And reproducible builds will be like one way of trying to work out like that's actually happened and how to prevent it and how to get it out of your.
Are you open, Chris? Are you open to questions as you discuss?
Of course.
Or?
Yeah, please go ahead.
Hi, Dave Stewart. I'm at Intel. We actually had we've had a number of conversations about this, and one of the questions that I asked in a simple sort of way was, understanding supply chain vulnerabilities. It seems like what a reproducible build. I'm looking for the sort of small kernel of truth that I could help people to understand, the value of something like this, because there is work to get there, right? So the question is, right, if somebody has created a binary from a source project, right, and it doesn't match up with the sources that you build, then it's like, okay, we got a problem. Somebody's adulterated the binary independent from the sources. So that's a good check. But if somebody has adulterated the source, then reproducible builds just say, we were able to reproduce the adulterated thing, right? So it's important to understand what this protects us for. It protects us from somebody, pirating in a binary, right, that is adulterated. But if you go and adulterate the source, so if your source supply chain is not, well protected, this reproducible builds won't help you. Do I have that right?
You're absolutely right, Dave. And and just to, perhaps we should go from the top down so everyone's definitely on the same page. So the reproducible builds, the idea basically is that you can always view the source code for like malicious flaws. You can submit it to external third-party validation checks, if the name of it, blanking moment. Sort of third-party audits. You can audit internally. You can do. You can make sure that your source code is passed between various organizations and passed your build processes in a secure way. But most people actually end up ingesting pre-packaged or pre-compiled binaries into end user systems. So for example, when you can download the source code for the Signal app on you through GitHub or wherever they're hosting it. But when you go to your phone, you go on the Play Store or even the F-Droid store, and you just say install, and there's someone's already compiled or pre-packaged, or basically you're trusting them to have taken the source code and do it and take it to a binary. And so the idea of reproducible builds is to be, and if you assume that person's untrusted, or you don't necessarily want to trust them, so even if it's you that's compiling it, but you can't trust that those machines that you're using haven't been compromised without your knowledge. You basically want to be able to trust that process. Like go skipping right to the end, like be able to trust that the process hasn't been compromised. Yes. So Dave, you're quite right. Like if you don't have trusted source code to begin with, you can't necessarily end up with the binary at the end. So yeah, we do have this kind of like I forgot the word in philosophy, but it's where you have. You just stop at that point. You just basically assume that the source code is trusted, which is obviously a complete nonsense. But it's just out of scope for reproducible.
Yeah, no, that's good. I mean, when I first heard the concept, I was scratching my head because mostly I was thinking about upstream stuff like securing the source code, and it's like all the, not only just the source repositories, the build chains, the deployment, all of those other things, right? And then it's like, oh yeah, so this is a part of it. So I think I get it now. And it's a hard thing just to get reproducible builds, right? That's turns out to be difficult anyway. But anyway, let's
yeah, I mean, that's difficult enough, and securing all parts of the source. And it's all about surface area. I mean, everyone here knows all these things. So it will never be the most impregnable system, and even if there was, it would be completely useless. I mean, maybe I'm just thinking of Mission Impossible and things like that. Curiously, though, there are sort of bleeds between the two. So actually, in the process of getting a build reproducible, you can often find security holes in the original source code. Like due to the way that the reproducible builds, we do the testing and things like that, sometimes when it can display two differences between two builds, or if it shows that there isn't any when there should be, and things like that. And you can actually infer a security vulnerability in the beginning. So I've got a couple of CVEs simply from doing reproducible testing. It's actually been like, oh, well, I shouldn't be getting this result. Cut a long story short, this is because there's actual security problem to begin with, things like that. So yeah, or I can, yeah, anyway, I'll just leave it at that and stop waffling over you there. So.
Yeah, so I think what I'm hoping most people from that brief description, reproducible builds, you can reproduce the build repeatedly by different organizations and show that the result's the same. I guess the question would, for a lot of folks, would be, how difficult is it for various projects? And I'll note, I'll note that the reproducible builds has had great success in reproducing a lot of things individually, but those things aren't necessarily upstreamed in places like Debian yet. So it might be helpful to get an understanding of how hard and what's hard, what's easy, because I realize it's how hard it is depends on the program. But what makes it easy? What makes it hard?
Well, you're absolutely right to split those things, and I think one difference you did make implicitly there is the sort of the technical and the social changes as well. So if a given project, it's whether to make it reproducible will often depend on what sort of software stack they're using to begin with. So if they're quite a traditional C-based program and quite small as well, I mean, size is a big thing, it'll be fairly easy to make the build reproducible in a technical way. That's completely orthogonal to, say, trying to get those changes into the upstream repository. If the upstream developers don't consider this a high priority for whatever reason, whether that's mindshare, in extremely rare cases, they think it's a silly idea, but that's ignoring those people. A lot of people just don't really see it, or they can't test it locally on their own machines. So they're unwilling to apply patches that they don't see any benefit to them immediately, even though they can see the conceptual benefit. But okay, reproducible builds is really nice for them. So yeah, but and then often like the tool chains themselves that the program uses will often dramatically make it more or less difficult to make a build reproducible. So I mean, make it up. Like Rust having currently problems right now in the Rust tool chain of trying to get it to generate reproducible builds at the end. It's just a little bit of a problem. Or .NET, if you're building sort of .NET applications on Linux, they contain some sort of randomness and things like that. Technical details aside, that's not anything implicit in the piece of software. It's just in the tools that they're doing. So yeah.
I was going to comment about some projects are trying to help the overall, sort of upstream. I know a Yocto project was working on reproducible builds. I know not everybody uses that, outside of the, the embedded IoT space, but I know that's been a big effort there.
Yes, Yocto's been quite good. Yocto's been particularly good because one difficult thing is to make an entire sort of ecosystem reproducible sort of in itself. So David is right to imply that the Reproducible Builds project has had a lot of successes in like individual projects, and then some proportion of those we've managed to get those changes incorporated into the upstream repository. We do have some, or of a far fewer success projects about entire, what would you call them, sort of architectures, ecosystems. One in particular we can trumpet is the Tails operating system, the one that's like it's a USB-based operating system for privacy, things like that. So you can everything that you do under this thing, it runs under Tor. It's deliberately designed to not leak any information, so it cuts out metadata from images and things like that. It's I think most famous because it was the one Snowden used to talk to Glenn Greenwald and things like that. So he's got a bit of news written about it. But yes, I worked with the Tails project and made their distribution reproducible, which means that from their point of view, it means that they feel a bit more trust in their own build servers, which are generating these images which everyone's are running and relying upon. And it also means that they, as developers, become less of a sort of directed targets, because they felt that if they built these images on their own machines and they were being run by dissidents in wherever, then they felt that they could become subject to attack by even nation states and things like that. So they have different motivations than people on this call might have, but it's the same sort of thing where they didn't want to be. Yeah. Anyway, just been repeating myself there. Yeah. So.
Chris, is there a place where we can point projects to that want to make themselves become reproducible in some senses of best practices they should follow?
There is the Reproducible Builds main website. There isn't a perfect page for that use case. And a lot of it is just in per project feedback. So if you were just to run a project, they don't often know whether they are reproducible. And so they could make some of the changes that are on this hypothetical page, but they wouldn't know whether they had any real impact and things like that. And documentation is perhaps one of our, documentation and mindshare is one of our weaker points as a project at the moment. We're always trying to address that and things like that. So, but that's really useful information that really useful data point.
Yeah, like for instance, I'd like to see if we can get Zephyr in the stage.
Say that again, sir?
I'd like to see if we could get Zephyr, for instance, as a project. And
It's a kernel.
It's a kernel.
Okay.
For sensors, actuators, that type of thing.
Oh, right. Okay. Nice.
So very, very small. But I think that, the project is pretty good about trying to do the best practices that they can find. And so I'd be sort of curious to see if we had sort of a checklist we could sort of work through in the security team or something like that.
Yes, I can certainly totally see why that would be really useful. Then the other component of that would be to some sort of validation.
Right.
So not necessarily as a badge or not accreditation, but they make a change to make themselves reproducible. Are they now reproducible?
Right. And is there some way we can check it doesn't regress either?
Yeah, if I can jump in here, I have an opinion on this, having had to do this for myself. I think there definitely needs to be more documentation, but the two big points I would have would be, one, the only way to make sure it's reproducible is to actually try to do it. No documentation in the world will beat the actually trying. And second, get it in your CI pipeline, and that way you immediately know when there's a regression.
Yes, I would second that. In fact, just scrolling back to what I said about Tails, that was the way we ended up doing it, adding it to the Tails release and development CI platform. So we caught regressions, and also it could just be automatic. It didn't require any real extra brain cells and things like that as we were going along.
Yeah, no, Zephyr's got a CI and infrastructure and so forth, and testing a lot of practices in that direction. It's just a question of where can I other than the top level website, I'm just sort of wondering, where can I point if there's other places I should be able to, come up with a checklist and then possibly contribute it back into contribute back into reproducible builds. Are you interested in, things like that?
Good.
Yeah. Kate, thanks. Actually, the question that raised is in your CI infrastructure. Are you saying, typically CI will, pull in all the sources and create a binary. That's a simple, oversimplified definition. But you're saying here something that will go out and check the binary that's been deployed against the sources. Whereas I think typically you would just, I don't understand exactly how you would integrate it into CI, because the CI purpose is to take the sources and create a binary. Are you comparing it against the binary that's already deployed? I don't get it.
Do it twice. Rebuild.
Okay.
Once you have a script
I
build,
I get it, David. Thank you. I get it. Okay. But do it twice, see if you get the same result. Okay.
That's right. Do it twice. Maybe I better add that to the notes right now. Do it twice. And I think it's remarkable how many little things get you. My experience has been, and please, I'd love to hear your much broader experience, Chris. The things I've gotten bit on, I guess I'm going to list as challenges are timestamps. Another issue is uninitialized values, uninit values, and I will call this random orders. I have a list of stuff. I yank it in. I don't care what order, and so and none of these are impossible. There's a spec for source data epoch environment variables to deal with timestamps. You can force just any arbitrary sort to eliminate randomness, but it's just finding them all and fixing them all that's a pain in the butt. Chris, what do you find to be the most common challenges?
Well, definitely, you're absolutely right to communicate that it's a lot of the sort of, what do they call it, long tail, a lot of small things here and there, and you're sort of not playing necessarily whack-a-mole, but you go, oh, here's a list that we aren't sorting, or here's we're taking in file names from directory which aren't sorted by convention, by the API and things like that. Timestamps are a really big issue as well. So yeah, that's definitely the main problems, things like that. Yeah.
Who would be the best person to talk to when it comes to reproducible builds in package managers like PyPy, NPM, etc.? I'm doing a lot of research in that area right now, so I would hate to reinvent the wheel, which I'm probably already doing in some cases. So is there any kind of person in that community that I could talk to? Or
in terms of package manager specifically, I don't think there's someone that I can think of at the top of my head that is sort of living that particular area. A lot of people in the Reproducible Builds project are coming from their own distribution. So I came to this via Debian. There's a whole bunch of folks from, say, Arch Linux and SUSE in particular, and they often come with their own, old history. SUSE will come with all their particular packaging. Arch Linux will come with their own things. So there isn't one doing a cross ecosystem package manager at this point. So a lot of this information is slightly siloed in different operating systems and different sort of PyPy and things like that, including things that aren't necessary distributions like F-Droid. So you have that's probably the same kind of problem from your point of view. So yeah.
Well, but with Python, aren't you? Maybe I'm mistaken. I'm just sort of thinking through this. If you're talking about the script itself, that you want to compare, I mean, there's not really a build, right? Or maybe
yes, there is. Yes, there is. Very, very few people actually run Python code as the script. If you're going to run Python, I would say 98% is pip install space name. And what pip does is it downloads a built package, a wheel, say, and how does that wheel get created? Oh, somebody takes the source code, runs it through a compiler. Well, it's not a compiler, but it's essentially, it's a packager. But it's the same thing. The source code is not what people are running. It's the packages. The same happens with JavaScript. The same happens with Ruby. Nobody, with a few exceptions, nobody installs packages as the source. They download the package.
Got it.
And there's many types of packaging. I mean, as you just implied, that even JavaScript, no one's running unminified, uncompressed JavaScript because it's just too big. And so even the process of taking the 120 kilobytes of jQuery and turning it into the 17 kilobyte version, that is essentially a compilation process. It's not, from a C point of view, it's not turning it into machine code, but it is turning it into something that's not the original source code. And if you're trusting someone else to do that minimization or compression, then you need to be able to trust the output of that, because otherwise you have no idea what you're distributing on your homepage, which is, I hear that could be a problem. So yeah.
Hey, one more quick question, Chris, while I am thinking about it. So for Linux, I know the kernel is wanting to create some randomness between, functions, right? This is a way to, try to discourage people from being able to know where the address of things. Right now, I think I may be wrong, but I think this is like has to do with, is that a load time issue as opposed to a binary issue? In other words, if the binary should be the same, but where you load those binaries will be different. I mean, you know what I'm getting at?
I think I know what you're getting at. There's two distinct issues. I think the one you're referring to is address space. Blanking. Sorry, it's terrible with this thing.
Randomization. I think there's a address space randomization. ASLR. Yeah.
You're right. Thank you very much. And that's unless I'm getting it completely wrong, that's a load time thing. So the binaries, if you have an ASLR binary, it can be the same thing. It's interesting you choose the kernel example because a lot of kernels touch on, they want to get signed binaries. So you have this sort of secure boot style arrangement where you have things like that. And that involves cryptographic signatures.
Right.
And you can't necessarily ship the private keys for your kernel to all of your, you can't exactly put that on your GitHub because, it's a private key, blah, blah, blah. So yeah, there's a two slightly different but related problems to do with kernels and things like that. But in the one you're thinking in terms of runtime exploits, vulnerabilities, not having predictable memory jumps and things like that, that's completely fine. That should be a completely runtime randomization and things like that. So yeah.
Thank you.
There is a related issue, but it's also easily solved. There's some stuff called preloading. I'm not sure if you're familiar with this. Fedora uses it, and I think all the Red Hat ones do, where after you load it, they will occasionally re-randomize the locations of the layout. And this is basically an optimization. Instead of trying to do it at runtime, they try to do it ahead of time a little bit. But this is not really a problem because you just, before you do this first shifting around, check that it's the file that you downloaded was the one you expected. So it's just a matter of checking before you do these optimizations.
Another very related problem, and perhaps to do with which people, is profile guided optimization. So that's an unresolved issue. So profile guided optimization is that when you're doing the very highly simplified, when you're doing the compilation run, you also run the program at the same time, and you say, oh, these particular code paths are the most common used, so we'll rearrange the binary so when we actually run it on a modern architecture, it's very fast. It makes it difficult to reproduce that exact compilation phase later because the decisions made based on the profile guidance are essentially non-deterministic. It could depend on the CPU load of that server and things like that.
I think with Pogo though, those sorts of things are stuff that you would typically put as part of. I mean, right? I mean, usually. Maybe I'm wrong, but I mean, it seems like you do the profile guide optimization as part of the original build where you distribute the thing. You leave the profile alone, and you change the profile only when you change. You make a code change basically.
Yeah.
Well, that you can. Sorry, go ahead, Kate.
Yeah, there's also, I believe, there's data files that are generated as the monitoring is going on for the guiding, and then should not that
the profile?
Yeah, from the profile, should not that information then be fed into a subsequent compilation, but should not that type of information be able to be logged to get the reproducibility?
Yeah, yes. That's my point. It's as much an artifact as the rest of the sources.
Right.
Unfortunately, that's not typically the common way people are using it right now. People are just turning on the EGO slit and thingy. So yeah, you're absolutely right. If they persist that the optimization output, then yes, you can combine the two again and get the same result later in theory.
Right.
So, yeah.
What's the status right now with the compilers? Are they like is a GCC binary considered reproducible at this point now, or not? I've been using the make and so forth.
Just to, do you mean are the compilers themselves, or are they generating output that's reproduced?
No, I'm thinking the compilers themselves. Again, turtles all the way down. Making sure that we have the full reproducibility. Like, there's 3 stages to actually build the compiler, right? I'm just wondering, have the compilers itself, the GNU tool chain itself, are all the elements of that considered reproducible at this point?
Well, actually, David, can I just loop you in here because you recently wrote something up about the bootstrappable tiny CC.
Right.
Do you know the current state of the art? I'm about 4 months out on this one.
Yeah, I mean, this is an area where, unfortunately, I'm trying to figure out how to speak without dumping way too much on this. I haven't checked recent versions of GCC, but to my knowledge, GCC itself reproduces itself. I haven't checked the latest version of GCC, but certainly I have in the past been able to get GCC to reproduce itself. There are some nits when you deal with C++. There's a seed parameter where it will normally, in certain cases, the C++ compiler will do things randomly, but you can force it to not be random. So so I believe the answer is yes. I haven't checked more recent versions. There's some nits involving --c, seed --seed. I'll try. All right. So now there's a separate issue, somebody mentioned turtles all the way down. You always worry about what the attacker is going to try next. Clearly things like SolarWinds have shown that there's attacks possible on build systems, and reproducible builds helps with that, because if you give them the same source, same tools, you produce the same results. And if that doesn't happen, then you've got a subverted system. There is an attack that is famous from Thompson's reflections on trusting trust. And that's if the tools themselves are subverted. So this is a whole nother layer. First, is the source code bad? Okay, if the source code is okay, maybe the build is subverted. What if the tool what if the build process is okay, but the tools are subverted? That's the trusting trust attack. I actually wrote my PhD on this topic, and there are countermeasures for that. The two best known countermeasures are bootstrappable builds and diverse double compiling. So the good news is, if you get down to that level, there are countermeasures. There are bottom turtles. But right now, I would argue, and this is somebody who did PhD work on DDC, right now, that's not our primary problem. Our primary problem is that we can't reproduce the basic builds, and if somebody subverts any build, never mind I attack the compiler to attack another program to finally get it out, which is devastating, but a much harder attack to pull off.
I don't know if this has been brought up yet, but there's also the JCenter, like the JCenter shutdown issue. I don't know if this has been brought up earlier today. Like you can have like the places where your dependencies are coming from just get shut down, and then the build just can't be reproduced either.
Yeah, I'm gonna sort of very subtly put on the umbrella of reproducible builds having a good idea but a kind of rubbish name, and that's one of the problems that we don't necessarily put under our remit. If you just denial of service py.org, then that's a slightly different problem to one that reproducible builds is doing it. It's a huge problem, and there was a big and there's another one yesterday about sort of typo squatting unused node modules. Was it yesterday? I can't remember what it was. Like a big one in the news.
Node and pip, both of them.
Oh, really? Both? Okay. Yeah. So these are huge issues as well. Often we find that when people make their entire toolchain reproducible, though, as a sort of side effect of better sort of software hygiene, you get a bunch of extra things. I'm not going to say for free, but you got things that you get sort of slightly automatically. So, for example, you stop pulling down things from random things on the internet, and therefore, because you need that to get the reproducible build in sort of my narrower sense. And it means you don't end up downloading stuff from the internet that you don't necessarily trust. And so that problem sort of fixes itself in a way, but just as a helpful side effect and things like that. Yeah. And it can also, it has other side effects as well. So for example, you have a much better idea of what's in your software, which can be just for having a good software bill of materials, which a lot of people care about. And if you're just doing an audit of what software your build process is ingesting, you can also find, you could be violating some legal agreement. You could be, using some proprietary software or some GPL compatibility issue as well. So you get a whole bunch of stuff as a result of getting your build reproducible. That's not necessarily reproducibility related, but it's all in this sort of software integrity, software supply chain area as well. So yeah, but you're right to raise all these other platform attacks and things like that. Thank you.
Have you tried to use the defo scope, for example, to compare different versions of the same package? What I found out is that, well, the reproducible builds essentially boils down to doing like diff on steroids between what you build versus what is being published. And I found that if you apply the same diff engine to different versions of the same package, you can basically verify your audits that the changelog is correct because it's written usually by human. And in some cases, for example, like the SolarWinds attack, you don't even have the source code because it's commercial tool, but you have the published binaries and you can audit it yourself, like what changed between version 1.0 and 1.1, and you might see some unexpected changes in the authentication layer, for example, hinting you should like do some kind of security audit. Have you tried to apply it also this way?
Yes, and in fact, personally, I use that almost every day. When I'm upgrading various bits of software, I do some security releases. I do some security updates of various bits of software, and so I'll take upstream's patch, apply it to the piece of software, and rebuild it. So it's hopefully been plug the security hole, and I'll do a diffoscope on the pre and post patch versions, and I check that the only changes that I've made don't include any accidental changes, and only include the change of the if, the change of the adding the addition of the bounds check, whatever the problem, whatever the solution I'm trying to add to the piece of software. I just make sure so I'm just auditing myself and things like that. In terms of SolarWinds and things like that, I've also used diffoscope to get, when I've got a new firmware for I think it was one of these old routers the plastic white routers. They provided some new firmware, and I was like, well, what's the difference between these two? I wasn't really serious, but it was very useful to run it on this this .bin file. It's an entirely binary file, and to try and work out what's the difference between them. And diffoscope was very good at totally disassembling these two firmwares and really getting to the heart of what's really different in them as well. And so even when it was nested within this horrible CPIO archive, and there was a tar in there and a binary and some other things like that, and some random text files. So it was really good at showing those two differences. And I use that a lot when trying to do fairly fail-safe and trying to put more trust into regular upgrades where the source actually has changed. So
that said, I mean, it obviously requires not just running a tool, but someone who has a lot of knowledge of what you're looking at. So while I think that doing the comparison is valuable for important software, I think trying to do that across all software is probably not really a starter. Whereas I do think that it's plausible to think that the vast majority of software can at least be built reproducibly. Comments? Yeah, Chris, you're welcome to disagree with my statement.
No, I'd agree. I would. I long for the day where all software is reproducible. Yes. Yeah.
So just some. So I work for Gradle, and the Gradle build tool, and the Gradle build tool is used to build Gradle, as is like the Kotlin compilers used to build Kotlin, right? Like turtles all the way down. We do some interesting things. So one of the primary focuses that Gradle actually has is on performance for people, and performance of your build. And one of the things that we do is we cache intermediate steps of your build. Well, when you use the Gradle build cache, which is something that you use and you are authenticated to, and you can only publish to if you're a trusted CI server, we cache intermediate build steps, like the Java compiler's output, because you may have multiple sub-projects in your much larger project. And so each one of those definable intermediate units, like the compiler run, the tests being executed, all those things, they can be cached as individual steps. And then when we see those same exact inputs, right? So we try to we hash all of your inputs. We upload a key, which is the hash of all of your inputs, to the value, which is the output. And then when we see the same scenario, the same input again, instead of rerunning the compiler, we just download your artifacts from that build cache. And so I have talked to my coworkers about, okay, like if we wanted to prevent the SolarWinds attack against the Gradle build, like what would you need to do? And I mean, what we've said is basically like if you wanted to do that, you'd kind of need to just build a version of Gradle without the build cache. And I think that one of the things that I remember talking to my coworker about was like, you would have to run 2 builds both without the build cache, because if you were to at any point use the build cache, like you were to compare the one that the build cache built where you used the build cache and the one that you didn't, you might still get differences because of like we intentionally ignore some things like ordering, or we sort things when we do the cache entry just to like make it so that we get more cache hits, to like, basically make it more user friendly, and so you get more performance if you're going to get pretty much the equivalent thing. So it's a like not, it doesn't need to be perfect. It can be good enough because that gives you enough performance, but it's not, that's not a good thing necessarily when you need these like guaranteed reproducibility requirements.
But it's really interesting that you is that integrated itself, or it's ignoring the ordering and things like that? I'd be really interested.
Yeah. I think that some of that stuff is integrated, right? Like one of the examples is right the order in which you pack a zip it can change the cache, right? So if you don't pre-sort the elements that you shove into a zip file, you can get differing hash results and stuff like that. So that it's that stuff like that are like optimizations that like when we're creating the hash key we say yeah, whatever, but like if you want true reproducibility you need to make sure that everything is sorted and stuff like that.
Gotcha. Yeah.
So Chris Lamb, I have a magic wand. I hand it off to you, and you're going to wave the wand and make things more reproducible. Or just what would be necessary to make far more things reproducible in the field? I mean, is it money? Is it do X? Is it some declaration on high that everyone agrees it must be done? I mean, what needs to change to get more of this?
I think it not necessarily mind share. I think anyone who hears about this problem and hears about its ramifications knows it's a problem, or it's just a. So I don't think I wouldn't wave a publicity wand, and I wouldn't necessarily wave a particular technical wand, but I would basically have tools on all of the platforms, all of Gradle, blah 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 blah, so people could check whether their own software is reproducible. Because I think I've just from other large changes in software engineering, when the users themselves or the developers themselves have the ability to check something or are basically empowered to do these various things, then they start to get checked. So as soon as you had fuzzing tools available for your desktop, and it wasn't just some weird thing that random things are doing, then people started to fuzz their own software. Once you got sort of static analysis software on your own machine, you didn't offload that to some other company that you might have done in the early 80s and things like that. So basically, having these tools. So yes, I would probably, wave a magic wand so we'd have money so everyone could have these tools in their own machines, things like that. But yes, having it in all the big CI systems. So if GitLab and GitHub all had all the etc., all had these things to say, am I reproducible or not, and why am I not, and things like that. Just knowing yes or no would be probably the biggest single magic wand. I'm assuming this is a single fire magic wand, otherwise I would just wave all day.
You can fire it multiple times.
Well, that would be probably the priority order. I mean, because yeah.
I would argue in open source though, you mean throwing money at not just throwing money randomly at the problem, but like a financial, right? Because like I remember I had a couple of coworkers when the Google blog was posted, and like a couple of coworkers were talking about some Twitter conversations in French about that blog post, and like some people who are open source maintainers were just basically saying, like, you know, the way this article reads is like Google expects that open source maintainers will invest their time to make their CI pipelines more secure, right? Like without putting any financial backing behind it, right? That's like not a good way. And so if you want to incentivize, right, like you kind of need to finance this thing that's not a core feature, but it's something that you consider valuable for your security, right? If your organization considers this to be something that is important for your security, you need to like be willing to put money in front of that goal. And sometimes that's not even just a pull request, right? Because the pull request, right, may not necessarily intersect with the knowledge of what the maintainers actually know about the build. And so like that pull request may take a lot of effort and resources on behalf of the maintainers to like even get merged. And so I think that a financial incentive system, both on behalf of the people that are going to be fixing the thing to make it reproducible, but also the maintainers who are accepting this into their build, to be like, we will financially incentivize you to not just have your build reproducible, maintain it to be reproducible in the future. That makes Reproducible Builds a customer of that project.
That's an excellent framing. Yeah, and that doesn't necessarily reverse the relationship, but yeah, I see how that would completely change the dynamic of adoption, or whatever you want to call it. Yeah.
Oh, you mentioned about the making it easier for developers to figure it out. One thing that I have mooted briefly, I'd love to hear your thoughts about this, would be, getting into the various packaging repositories, both system and language levels. So when I submit a new package to PyPI, I go ahead, I build it, I send it in, and then PyPI rebuilds and either tells me, oh, you're still not reproducible, or hooray, you're reproducible now. And the same for Debian, the same for NPM. Basically, when you submit to a repo, it should be able to tell you whether or not it was able to reproduce it. Thoughts on that?
I don't think that any of those package maintainer systems want to be running arbitrary code on their systems. Like, I can imagine that's a security nightmare for those poor souls.
Oh, well, a whole lot of them do already. So whether you like it or not, I think that I want to totally separate the build it from the distribute. They don't even have to be on the same racks. I mean, you could run the build rechecker on AWS and distribute on Google, because all you care about is run a build and give me a cryptographic hash. That's all you need. It doesn't matter what else it does.
Are there existing services like this, like you're describing, David? The only one I'm aware of really is the Debian one, where there's all those rebuilders that publish their hashes.
Well, OSS Fuzz, for example.
That publishes hashes for builds?
No, but it takes arbitrary code and fuzzes it.
Right, I mean for the reproducible side of things.
Oh, no, not for...
I don't. There is a person inside of Google that I have a contact with that has pushed forward this initiative in the Java ecosystem. I can see if I can talk more about that, if I can get their approval to discuss that. But there's an effort inside of Google to try to get more of the Java ecosystem to do that, because there was I think that one of the things that scared them was there was an article published a couple of years ago about a vulnerability. It was if you Google a confusing dependency, that's the term, a confusing dependency. There was an issue with a Gradle build where you had two repositories, and somebody was able to publish something malicious in the right place, in the right order of the repositories that you resolve your components from. And as a result, a malicious version of a library was pulled down instead of the one that they intended to pull down. And that freaked out some people when it was discussed originally. So I can see if I can get more information about that.
I'd be very interested in that. Yeah.
I mean, I think we also want to talk about malware analysis, which is doing exactly that. Downloading and installing random packages and seeing whether or not they're malicious. So the idea of running malicious code in a sandbox off from the rest of the world is hardly new.
Oh, that I get. Yeah, I was just asking if you're aware of anybody doing exactly what you're describing for reproducible builds yet.
No, not for reproducible builds. I mean, the closest is, the reproducible builds folks have managed to rebuild the vast majority of the Debian packages.
And there are Debian rebuilders too that I've seen as part of like the Intoto project, where once you get enough people signing, like there are people running Debian builds and proving the reproducible and publishing signed hashes, but I haven't seen it outside of Debian.
Right. This is why I say it's something I would like to see,
Right.
not something that exists now.
Almost every time I would like to see something, somebody sends me a link a couple months later to something that's like 99% of the way there, and I just ended up missing it the first time. That's the only reason I ask now.
There's a reproducible build organization. There we go.
Yeah, that's Chris.
Yeah, that's Chris. That's why he's here.
All right. Never mind then.
But you know what? Actually, that's a fair point. I don't think we have a link in here to this. So I think we will, in our notes at the very, very top, I'm going to insert a link to the Reproducible Builds project, because that does seem like a relevant link in our notes. Sorry.
Well, this is one thing we aren't doing. This is another magic wand. It's sort of a bit of marketing and mind share and things like that. We're a fairly sort of low. We're all sort of volunteers and things like that, and we aren't good at sort of making a splashy website, and we're not very good at trumpeting our work and things like that. And that's certainly one thing I'd love to do more of, because a lot of the time people are just thinking, well, we don't have this already, or they haven't heard of us, or they haven't, things like that.
Yeah, I think that's actually key. I mean, you were saying earlier you weren't sure how important that is, but actually, I've now talked to several folks who basically said that SolarWinds was never possible to detect it, and they've never heard of the best known countermeasure. Well, they've never heard of this countermeasure because no one's ever heard of it.
Right.
I also think it shouldn't be understated how important the community effort and the impact would be if GitHub and GitLab were to signal this is important. Developers would take it a lot more seriously if there was some sort of tag on there that says this build is not reproducible, or this build is reproducible, and you get a fancy little badge or something. Because then users will ask questions. You'll start seeing people talk about it in comments. Well, this is a security risk if it's not reproducible, etc. And it's important to bring the community on board to the idea, I think.
I have a potentially dumb question, and I'm just curious if anyone has any thoughts on it, which is there a way, it seems like the only sources of non-determinism during the build process are basically coming from the environment, the build environment, specifically time and randomness, which would be both, coming from the kernel. It's probably not the right way to solve this problem, but has anybody tried fixing that build environment? Like, say, having like a container that will always return the same times when called in a certain sequence and the same random numbers?
Yes.
That's
first
not
of all, so go ahead, John.
Though, right? Like, because the other source is, right, what your dependents are. And if your dependent server goes away, right, if your dependency server goes away, that's also another input that can break. So it's not just the environment.
Yes, I also tried that as I'm building the system for checking the PyPy packages. So what I'm working on right now is to try to reuse the CI pipeline for that. Because most of the time, like, for example, you have Travis CI, and ideal use case that I found for developer would be to publish the packages using CI. That's the easiest for verification. Of course, you can modify the package by including some malicious data using environment variables, which then go inside the compiled package, but you can independently run the CI pipeline and check that against the what was being uploaded to PyPy, and that also gets you the same environment. Because I found out, for example, like it's not very easy if you want to reproduce something. Sometimes you need to specify some compiler flags or where the directories with the shared libraries are on the disk, etc. So it's very hard to do it in an automated way if you don't know how to do that. But if you have the CI pipeline file, you can use that to start at least the initial verification whether it's reproducible.
I have not tried it. I've looked into this a little bit. On Unix, like, well, at least Linux systems, there's an environment variable called LD preload that lets you intercept not just system calls but library calls to do a lot of things. But I frankly am a little skeptical. It's not just, for example, if you always return the same date time value, a lot of build systems will be completely screwed because they expect that something created later will have a later date, and they use the date timestamps to figure out what should happen when. Another problem is that it's not just system call environment variables. A lot of builds nowadays happen in parallel. If you've got 50,000 files to be compiled, you could do them sequentially. No one's going to want to. They're going to use something like make-j or something else to run everything in parallel. And as you well know, as soon as things happen in parallel, there is no sequential order.
Yeah. Hardware non-determinism. Yeah.
Yeah, you've got hardware non-determinism, and so it doesn't mean you can't have reproducible builds. Trivial solution is, for example, you do everything in parallel, and then you sort the results, say, by ASCII or Unicode code point numbers.
Mhm.
It's not a big deal to overcome it within the build, but that means you're modifying the build script instead of trying to make this universal solution.
But yeah, Mike, certainly not a dumb question at all. In fact, very early on in reproducible builds, some of the very first projects that were reproducible, Bitcoin and the Tor browser, they wanted to become reproducible because they didn't want to become targets for supply chain attacks. Because obviously, if you backdoor a fancy Bitcoin wallet, you become incredibly rich. So they actually had it in rather sort of Heath Robinson contraption where you had a VM. This is back in 2016. You had a VM that would build the software within the VM, and the VM would sort of lie to the underlying build system, but time was always fixed. The file system ordering was completely fixed and things like that. And it just tried to remove as much as the outside environment as possible. Obviously, if you're doing all of your builds under a very fixed VM thing, it becomes not very sort of developer friendly, user friendly, and things like that, or reproducible friendly. So from that extreme, you have, say, there's Debian on the other side that tries to specify as few fixed points as possible. So your build is reproducible on as many possible real world environments as possible. So whether you're building in sort of a New Zealand time zone versus Pacific time, it doesn't make any difference and things like that. Whilst you have other distributions in the middle. I think SUSE, for example, says, "Oh, we're always going to build in UTC. If you don't build in UTC, then you can't guarantee you're going to have a reproducible build," and things like that. And there's all manner of things in between and things like that. So it sort of depends what kind of philosophy and things like that. So yeah. And there's actually a project that goes perhaps to even more extreme. It's called dtrace. It's a university. I think it's one of the Beijing technology universities, and this was basically a Docker crazy thing that did all of this LD preload thing. It basically faked a bunch of non-LD preloadable syscalls as well, and it could actually resolve some of the parallelism problems as well that David touched on as well. But this is a quite a specialist tool that you could never tell the entire open source ecosystem to all your builds must be run under this crazy but cool little software as well. Yeah, so it's DE trace and things like that. Right, it's not that there's the kernel probing dtrace thingy, and there's the I'll fix it in the notes.
Yeah, if you would, because I think that's the wrong name, I'm sure.
Yes, I've got to jump in here. We're a minute over. Thanks a lot for the awesome discussion, Chris. David, I think, is catching up with links and all the notes here. Thanks for taking these as well, David. We were going to talk about the malware thing, but Jordan actually pinged it in Slack saying he couldn't make it today anyway. So I think we handled that and all those questions in Slack. So check out that channel if you had any questions about that. And yeah, next week I'll confirm, but we do have a demo of Tracy scheduled, which kind of ties into some of the stuff with crazy syscall monitoring. So if anybody's interested in that one, we'll confirm and send out another email as we get closer.
Hey, just I kept trying to add myself to the attendees list and kept requesting access to the file, but I've never been able to edit it. So if someone could actually add me, or just add me to the attendees list, but add me to the ability to edit the file would be super cool. I'm the other Stuart besides Kate. Yeah. So.
Sure. Yeah, I think I accepted you, but yeah, there's a group that anybody can join. It looks like we lost the instruction here. There should be a line at the top explaining how to do it. Yeah, there's a public group.
Actually, Dave, your Gmail's in there, but not your Intel one. Not the
Yeah. No. I use Gmail for all of my Google-oriented stuff because we used to be on a pilot